Hello everyone, my name is Samya Tanikonda. I'm a software engineering student at ASU. I belong to Team 32 and here are my team members.
Hi everyone, I'm Monica Ramakagari. I'm a software engineering student. I belong to the Team 32.
Hi, my name is Hemant. I'm a graduate software engineering student at ASU. I'm currently doing my second semester, SER502, Team 32.
Kirti Pendiala. I'm a graduate student in software engineering at ASU and I belong to Team 32 for this project.
Hi, I am Nikita Komineni. I am a graduate software student at ASU and I belong to Team 32.
All right, now let's look at some of the details that we're going to be presenting in this presentation. The first and the foremost thing that we're going to be talking about is the language description, the design, the features of the language, the grammar of the language, and the software tools that are needed to implement our programming language and the project, and the sample input programs, and a couple of sample intermediate form of codes, and finally the execution of our project. So let's look at the language description. So basically, our programming language is named as PyTel because it's a fusion of two different languages. One is Python and the other one is Telugu. The reason why we have chosen Telugu as our language is our affinity towards our mother tongue and its rich culture. And the other language, which is Python, it has been used to develop a lexer analyzer. And yeah, and it has been developed to be platform independent, and it has the file extension of .tel. The rest of the details will be shared by my other teammates.
Yeah, so walking you through the design flow grammar for language, an executable set of instructions written in the PyTel language with a file extension of .tel are sent to a lexical analyzer as an input source code. Later, the lexical analysis is done by taking this code and breaking down this code into small piece of code which is tokens. Later, these tokens are passed to a parser in the form of list. Parser compares the grammar and the structure of our code and generates a syntax tree. This syntax tree is later sent to the interpreter, which interprets the tree and gives the outputs in the human readable format. Later slides will be continued by our team members.
So these are the features which we have implemented in PyTel language. We implemented three primary data types: integer, string, and boolean, and arithmetic relational operations, assignment operators, and logical operators such as binary and, or, and unary not operator. We implemented if-else condition statement and three loops for while and for in range. We have used words in our Telugu language as keywords in PyTel language. We used Sankhya, Boolean, and Vacuum for representing integer, Boolean, and string, and Mariu, Leda, Kadu for representing the operators and, or, not respectively. And for the loops, we have used Koraku for loop to represent the for loop. We have used Ite for representing the while loop, and we have used Unte and Kakunte for representing if-else statements. And for representing the begin and end of our program, we used Arambam and Mugimpu. For printing, we have used Mudra. The remaining grammar will be explained by my friend Hemant.
Hi everyone, I'll be explaining about the grammar of the language. So the grammar of the language will be initiate, a block, terminate, which will be Arambam, the block, and Mugimpu, and we'll have the control statements, block segments, and conditional statements, relational operators, etc. in the grammar. I'll take a moment here to explain about our lexical analyzer file and also about the TLP, TL.pl file, .pl file. So here in the lecture, I'm sorry. So here in the lecture, first the file will be checking for the .tel extension, and once it checks through, it will initialize a token and read to the file content. Once it reads to the file content, it checks for the non-empty strings, which will be having which will be checking for the null values or UTF-8 characters and quotations, and it will also be checking for the opening and the closing square brackets, and the other tokens will be involved. Here are the double quotations, not operators, and the curly brackets. And here we also have the code here. We also have the code here where the custom lecturer will check with the input file from the command line arguments. And the .tl file, sorry, yeah, and the .tl file here, this is the starting point where the lexer file will be taking the content of the input file, and it will be rolling going through the input file, checking for the tokens and processing the tokens and loading it into the Prolog code. Here we have some written statements which will display our programming language authors, and etc. So basically the code starts from here where the program will be token program will be initiated, and here we have the Prolog based parser interpreter for the custom programming language called PyTel. The code is divided into several sections, each handling the specific aspects of the language, and the entry point being the lecture file and the input file. The program header program predicate is used to pass the tokenized string and build abstract syntax tree. The parser interpreter are built using the definite clauses grammar rules. These grammar rules define the syntax of the language and how to interpret. They include the rules for passing the block segments, program instructions, and variable assignments, data types, control structures, and expression. Parser interpreter handle various program constructions like loops, conditional statements, automatic booleans, and automatic Boolean expressions, output statements that are written all over here. And we also have a helper predicates. We also have the helper predicates here, which will be provided for searching, modifying, verifying variable statements in the environment. And we have the validate program here, which verifies the rules with the language of the code and the syntax of the code, which will be explained by my friend Nikita.
This part of the Prolog code will check the validity of our input program by passing its tokens and checking for the semantic and syntax errors. The code consists of the set of rules that validate different elements of the program, such as the program itself, block segments, program instructions, variable definitions, value assignments, and Boolean expressions. For example, here the validate program predicate takes token program and resultant environment as input and validates the program by calling the program validate block state segment predicate. In the same way, the validate program instruction predicate validates different type of program instructions such as variable definitions, value assignments, and Boolean expressions. And the remaining part of the code will be explained by my friend Kirti.
Yes, this predicate here represents the print statement. Validate calculate solution. This predicate takes three arguments, which are like token, current environment, and the resulting environment. It interprets the pass tree using the interpret ch theory, which search for the reference ID in the current environment and prints the parameter using write-ln. The next lines of code we have is like if condition, if validate condition. This predicate also have three arguments. As you can see, it validates the condition variables in the current environment using validate condition instructor or validate expression boolean. The next few lines of the code is for the while loop execution. The condition validate while. It validates the condition in the current variable using validate expression rule or validate condition instructor. If the condition is true, it validates the block segment using validate block segment. And the following few lines of code represents the for loop. Validate control statement for. It validates the initial statement in the current environment using validate define or validate assignment. It then iterates through the loop statements until validate cycle or validate expressions until the control term is reached. And the next lines is for the range for range loop. This code defines two predicates, validate control statement for range and iterative looping statement. This predicate validates control flow statements that uses a range and iterates over loop and statements with a control variable and a range. Next will be continued by my friend Monica.
Coming to the next set of slides, this set of code is written to validate the ternary condition where we check one variable based on whether it's true or not. If it's true, we'll go to the variable 2, or else we'll go to the operation 1 based on the condition. So next set of lines are similarly for the increment and decrement of operations. So here it interprets the value of expression, searches for the variable, and retrieves the data and increments and decrements by one value, and then modifies the value to it. Coming to the next set of slides, so this set of lines are written to validate the summation, subtraction, multiplication, and division of these are mathematical operations, and this set of code is written to take the input number or string. Next will be continued by Hemant.
Hi. So now let's look at the different sample program files we have created, and let's try running them and with the language we have created and see the output. So first we'll initialize the SWI prolog from here, and once it is done, we'll take the tel.tel.pul file which we have created. So it is run now. Now we'll be checking for the AND operator. Sample program file which is running, and we get the output as no equal to true. So let's now look at the code part. So in the code part, we have defined as Arambam and Mugimpu, which is the begin and the end, and Sankhya is integer, Vakyam being the string. So 38 yes and no, and Unte is F. X is greater than 10, Mario means and X is less than 10. So it's generally checking X is greater than 10 and it also is less than 30. But 38 is greater than 10, but it's not less than 30. So the return value will be Mudra A, which is print A. So here the print statement is no. Now let's run the next program. So now we will be checking for the arithmetic operations, and when we run it, we get the output of the different arithmetic operations we have done here. We have done addition, subtraction, multiplication, and division of 10 and 20 has the integers. Now let's look at another program where we have taken a for loop statement and printing digits from 0 to 12 with an increment of 3. And here, so 0369 is the output. Now let's look at another program where we have taken if else statement and in runnings and say checking the output of here. So in the if else statement, we are taking xy and 728, where if it's 7 is not equal to 28, then we are printing the 7. So here, that's the output of it. And lastly, we are so lastly, we are checking the string, and we are taking the string and the integer and printing it as this PyTel programming language. Now let's go back to the slideshow and see. So these are the tools we have used: lexer and result, Python 3, parser, interpreter, compiler, and SWI prolog. And this is the sample input program which I just showed, string test.tel, and this is a sample intermediate form of code. And we have the sample program output, and this is the prolog term execution results in the online SWI prolog of the string test.pl file, and this is the pass tree that is generated in the same online software. So thank you everyone. This is our PyTel programming language which we created with the fusion of Python and our own mother tongue Telugu.
Thank you all.
Thank you all.